Hello class and welcome back to another video with Mrs. Struble. In our previous video, we worked on solving systems of linear equations by graphing them and noting that the solution was the point at which those graphs intersected. There are multiple ways to solve system of linear equations, as I had mentioned in the previous video. In this video, we're going to learn how to solve systems of equations by using a process called elimination. Now, in the process of elimination, let's provide an example here so we can best see what's going on. What happens is we're taking those two linear equations and we're noticing that we can easily match up the terms. And essentially what we're going to do is we're going to take both of these equations and we're going to add them together. So we're going to add everything together with everything that it matches. So in the x's here, we have 3x plus x. That gives us a 4x. Now the reason it's called elimination is because before we do that, we make sure that one of the variables go away. So one of the variables are going to end up canceling out or being eliminated. In this case, we have a positive y and a negative y. The y's get eliminated from the entire equation when we're adding these two linear equations. And we get 4x is equal to 1 minus 5, negative 4. Okay. Then we continue on solving for the variable that's left. So right now our equation is, we've started with two equations and now we have one in order to solve for x. We're going to divide both sides by 4 and we're going to get x is equal to negative 1. Okay. So in this case, x is equal to negative 1. However, that doesn't tell us what y is. And remember, a solution of systems of equations is an ordered pair, a point. So we need an x and a y. Okay. After you get done with this part in the process of elimination, then we're going to take this value that we found for x and we're going to take it back up to one of these. I'm just going to pick the second one. We're going to substitute it in order to solve for y. So if x is negative 1, what is y in this second equation? Well, x is negative 1, so x minus y is equal to negative 5. Okay. Solving for y, we're going to add 1 to both sides. And we're going to get negative y equals negative 4. Therefore, y equals 4. Okay. Now, it's always a good idea to check, and here's how you would check your answers. So right now we have a solution of x is negative 1 and y is 4. So our solution to this system of equations is negative 1, 4. Again, how do we check it? We go up to the equation that we did not use the second time. So if x is negative 1, is y 4? Is this all equal to 1? So 3 times negative 1, negative 3, plus 4, you bet, that's equal to 1. So we know that our solution is correct, negative 1, 4. Let's go ahead and try another one because sometimes these can get a little tricky. So here's another example. Say I have the system of linear equations 2x plus 3y equals negative 4, and then the other linear equation 2x minus 3y equal to 8. Now again, when we line up the terms here and we look at the equation, we notice that the 3's are going to cancel out, which makes it nice and easy for us. So again, process of elimination means that one of those terms are going to be, or one of those variables are going to be eliminated, and then we'll find the one that's left. We'll use substitution in order to find the initial one that got eliminated afterwards. Okay, so here, plus 3y minus 3y, that gets eliminated. Let's see what happens to the x. 2x plus 2x gives us 4x. And then we have negative 4 plus 8, that gives us 4. In this example, x is equal to 1. After we have found x, now we need to find y. So we need to go back up to one of these equations, and let's pick the top one this time. It really doesn't matter, whatever one you think might be easiest for you to solve. Everywhere we see an x, we're going to put a 1. So our equation is going to be 2 times 1 plus 3y equals negative 4. We need to solve this for y. Well, 2 times 1 is 2. So simplify it using that. Now it's a two-step equation. To solve this two-step equation, first thing we're going to do is undo the constant on this left-hand side. So we're going to subtract 2 from both sides. We end up with 3y is equal to negative 6. Solving for y, divide both sides by 3, we get y equals negative 2. Check to make sure it works for both. Substitute x or 1 in for x and negative 2 in for y and see if we get 8 in the second equation. So 2 times 1 is 2 minus 3 times negative 2. Well, 3 times negative 2 is negative 6. If I minus a negative 6, that's really adding 6. So 2 plus 6, yep, we got 8. Our answer is final, 1, negative 2. Okay. All right. So what happens when it's not easily eliminated? For example, 1 plus 4, or excuse me, x plus 4y is equal to negative 5, and then 3x minus 2y equal to 13. In this example, neither the x's nor the y's will easily be eliminated. In order to make it so that we can eliminate one of the variables, we're going to have to take one of these equations and multiply the entire thing by a number. Sometimes you'll end up having to take both equations. More often than not, if you have to take both equations and multiply everything by a number, then you're better off just using a different means to solve it. Okay, so let's see, we've been working with eliminating the y's. Let's try and eliminate an x here. Okay, so I see a 3 and an x. Well, that just means 1. I want them to cancel, which means I want one to be positive, one to be negative, and them to be the same coefficient or the same number in front of the variable. So what I'm going to do is I'm going to take this equation and I'm going to multiply the entire thing by a negative 3. When I do that, I'm going to get negative 3x. Well, negative 3 and positive 3 is going to cancel everything else out. Okay? However, I need to be careful because now I have to multiply every single term by negative 3. So this 4 plus positive 4 needs to be multiplied by negative 3. Well, 4 times negative 3, that's negative 12. This negative 5 needs to be multiplied by a negative 3. Okay, oops, and you know what? Let me go ahead and leave the original there. That way you can see how they changed. Okay? All right. So the positive 4 times negative 3, that's negative 12. And notice I took the sign in front of the term because that is the sign that it goes with. It is a positive 4y. So now it's a negative 12y. And then negative 5 times negative 3, that's a positive 15. Okay? Now let's eliminate the x's and see what we get for y. The x's go away. That was a job well done. That's what we wanted. And then we have negative 12y minus 2 more y. So that's a total of negative 14y. And then over here on the right-hand side, we have 15 plus 13. So that's a total of 28. Solving for y, we get y equals negative 2 because we divided both sides by that negative 14. Okay. We still need to find that x. So everywhere we see y, we're going to put negative 2. Pick an equation. I'm going to pick this bottom one because we haven't messed with it. Everywhere I see a y, boom, there's a negative 2. And remember that 2y means 2 times y. So we're going to do 2 times negative 2. All right, let's solve this for x. We have 3x minus 2, negative 2 times negative 2. So this is a negative 2 times a negative 2. That gives us a positive 4. Remember, the sign in front goes with it. Okay, so this is basically saying adding negative 2 times negative 2. Okay, solving this equation, subtract 4 each side. 3x equals 9. That means x is 3. Okay, so our solution here is 3, negative 2. And that's how you do it if there is not a variable that's easily eliminated. Okay. Let's go ahead and give you some problems that you can try on your own first before your assignment. Okay. The directions are the same. Use the process of elimination to try to solve the system of equations. Okay. So here's number 1. We're going to say if y equals, oh, we didn't talk about one like this. Okay, we're not going to get in that deep. I'm going to skip that one. We'll talk about that next time. So 3x minus 7y equals 12, and 3x minus 12y equals 6. Okay, oops, that's first problem. Okay, the second problem, let's go ahead and do negative 5y plus y, oops, negative 5x plus y equals negative 2. And then we'll have 4x plus 8y equals 6. All right. The third one I want you to try is negative 2x plus 2, that's not a 2, 2y equals negative 18. And then the second linear equation in this system is 2x plus 5y equals 4. Okay. Let's maybe do one more. These are a little more hefty as far as the workload in problems, so you can expect to not to be assigned too much, at least in this class for these types. Let's do 3x minus 6y equals 2 and 4x plus 3y equals negative 1. Okay, that'll give you sufficient practice. And remember, when you're multiplying one of these equations by a specific number, in order to make sure a variable is eliminated, for example, here we have a 3 and a 3, but they're both positive. So to eliminate it, we need to multiply one of them by a negative, one equation by a negative. And you have to do it all the way through. So I'm going to start you off on number 1 here. If I take the second equation and I multiply the second equation by a negative, that means I'm going to end up with a negative times a positive 3. That's going to give me that negative 3 that I want, right? Okay, I got to do that to every single term. So I'm going to multiply every single part of this equation by a negative 1. So here we have negative 12y. Multiply it by negative 1, I'm going to get positive 12y. 6 times negative 1, I'm going to get negative 6. So here's your new equation, negative 3x plus 12y equals negative 6. You can eliminate the x's now. in order to solve this system of linear equations here. Okay. Go ahead and give it a try. Assuming you paused the video and you tried these, at least the first couple,